So I think what we're seeing also with all the other presentations is we're moving into this space in which people are creating toolboxes or GitHub repositories to help other people also, fix their avatars more and more. And this is one more step. Precisely on animation of avatars, right? It's we're seeing already avatar libraries that are available. You can use these avatars for your work, but it's very hard to animate them, and we're trying to solve that by creating a series of projects that are very plug and play, and kind of bringing inside the avatar world people who are not on computer science departments necessarily. So we had a bunch of collaborators for this work, and I will start by saying, yeah, for animation of avatars, traditionally, to get high quality, you need to feed users with these full body suites, and it's an expensive capture setup with cameras around you, and it's something definitely we cannot bring home or to many laboratories. So you can get great results that way, and this paper by Mel Slater in SIGGRAPH has very interesting experience of what people really like about this full body experience of recording your avatar, and you can do it in real time, and the results are great, but as we were saying, not everyone can get there. So I want to show this small work that took 6 months preparing. And this is an avatar that was recorded from an actor.
I'm ready to begin. Are you also ready? Yes.
So what we did here is we get this avatar, we recorded the actor, the video, the audio, the emotions, and interactions with the person. Quite a lot of animations here. Eventually they become quite shocking. What we were doing here is a representation of the Milgram experience to obedience to authority experiments. And, it took 6 months to prepare this thing. And we're like, okay, this is not accessible for other people. So what we're trying to do here is using the Microsoft Rocketbox avatars, which are available for everyone to use.
Realistic avatars are an essential component for creating social interactions in virtual reality. Realistic avatars are an essential component for creating social interactions in virtual reality. However, the main issue faced by small labs is a lack of simple self-creation animation tools. In this paper, we present MoveBox, a plug-and-play toolbox that aims to provide resources for motion capture and animation of the Microsoft Rocketbox avatars without the need for professional equipment.
So the cool thing about this avatar is that it took as long as it takes to replay to record. So I think that's the big change of what we're trying to achieve with the MoveBox. MoveBox, it has multiple boxes inside. I will go a bit around that, but the main idea is that you can use real-time animation, record it, and play it back. And for doing that, we use either real-time depth sensing cameras like Kinect version 2 or Azure Kinect. We use the Rocketbox avatars, which are rigged. We do skeletal tracking and transformations to adapt the skeletons from these cameras and the skeletons that come with the avatars. And then we also have other parsers for example, for simple body skeletons. So you can use things like the Vive by Max Planck people to do offline video motion recovery. Sorry. And then a few other small tools like, small lip sync with audio. You put audio blinking, so you have minimal facial animations, and things like finger and hand animation for real-time embodiment. So let's go at this because it really is like 3 projects in one. We have the Capture Studio, which I will explain now. Then we have a base project for embodiment in which you enter and you see yourself inside an avatar, and you can have inverse kinematics of the upper body and finger tracking, all of these open source free. And then the third project is actually the simple parser that can be used, for example, to retrieve motions for archival footage of video. So let's go a bit and explore the Capture Studio.
Using depth sensing cameras, such as Azure Kinect or Kinect version 2, the toolbox can track a user's three-dimensional motion and transform that data into a full-body animation clip, which, combined with the basic analysis of an audio input, we can add facial animations so that the avatars are lip-synced.
Thanks to the bone structure on the face, we can animate the jaw for lip sync and add other facial animations such as natural blinks.
Using depth sensing toolbox also enables resizing capabilities. This scaling is done by measuring the foot and head joints using the depth sensing cameras, and then resizing the skeletal structure of the avatar accordingly. MoveBox allows for all of these features to be viewed and used in real time, but also be recorded for use at a later time or with different avatars.
So this part is, I think, is the key part that you can have inside. Let me try to go back to the
toolbox also enables resizing capabilities. This scaling is done
that you can have inside Unity, just this one controller to record and playback and put animation. So you drop that script into any of the Rocketbox avatars, and all of a sudden you have the whole studio in there. So there were some challenges. As we say, there is a lot of conversions on skeletons, right, that look very differently, even from Kinect version 2 to Azure Kinect, and also the own avatars, and the simple skeletal structure is also different. And then other small tricks that we did, like role compensation based on the data model. And all these things are embedded inside the system, and simplify and improve the quality of the animation. So the second project is this embodiment-based project. The idea here is you put on the headset, and with the headset and controllers, or if you have a Oculus Quest or some MRTK type of compatible device, you can have hand tracking and the head tracking, and then render an avatar precisely substituting the participant's body, right? I think the hand tracking also is great for manual tasks in front of the participant, which are very common for motion control or experiments related to rubber hand illusion, right? So this inverse kinematics and this hand tracking, everything is into this very simple project that you can also download from the MoveBox release. And finally, we have this simple parser, which can be understood much better if we think of it as part of something that connects the Rocketbox avatar with other work like the Vive. So the Vive is this video inference work that you can use any YouTube video or any prior archival footage that you have, and it extracts the motions and the body shapes of everybody who's on camera, right? It works pretty well when you have full bodies. It doesn't work so well when it's cropped, but of course this will improve. And the interesting thing is that we can transfer all of that very nicely to the avatars, so you can have archival footage. And this is super interesting for people who are working in social psychology, right? Like you can recreate a bar fight. You can recreate the camera that a policeman has been carrying, right? And record a scene, and then you can figure out for immersive journalism, for example, or, this idea that also you can recreate any prior scene that was not VR inside VR, all the videos that exist on YouTube. Explore social features, right? Like extract all the videos that feature 3 people playing together, some sort of, or talking together, and then extract social norms out of those videos and recreate on site, and create even your own motion banking of what do you want people to do and avatars to do. So you don't need even to have a deep sensing camera. You can use YouTube videos to record your own animations.
We validate our toolbox
And
using
here
both
we
the
have some validation of how good it works, no? How well it works, the whole tracking. Here you have the skeleton we retrieve from the particular depth sensing and the application to the avatar, and downstairs and down is the ground truth.
We validate our toolbox using both the Azure Kinect as well as the Kinect version 2. As a demonstration of the animation process, we perform upper and lower body movements and are able to view the resulting animation of the avatar in real time. Due to the lower joint tracking accuracy of the Kinect version 2, some joint rotations are measured poorly, the result of which becomes apparent when transferred to a full body avatar. To improve the Kinect version 2 results, in MoveBox we implemented a model-driven rotation compensation.
So one thing that I want to highlight here is that you can be recording while you're seeing another avatar play, and then you can overlap very nicely, which is something important, I think, for people who are trying to create a social scenario, right? That things need to be sort of in sync. So you could record an avatar saying a part of a script, and then the other avatar saying the other part of the script.
Our validation shows how MoveBox responds to different depth sensing devices and how better machine learning systems are helping in democratizing motion capture tools and avatars for end users.
So one of the cool things here is also in performance, right? We really put thousands of people with animations inside Unity. It runs real time, and it's great, you know, when you put the headset on and you're right in the middle of all these avatars dancing, and you know, these type of things which are very hard, and also shows the importance of these type of tools, not only for, you know, small social interactions. I think even crowd simulations could benefit very much of this type of tools. And I say creating your own motion bank, this idea that you have a pre-baked walking animation, or I think that that's going to be over as we have more tools like this. And my hope is that it's simple enough that moves away from just computer science departments, and you know, you have all these people trying to explore bystander effects, or in social psychology, how people behave on a fight. And you cannot go into a bar and start a fight, but you can start a fight in a virtual bar, right? So I think this source code and this MoveBox should help everyone on that regard. So this is the presentation, and I'm ready for questions.